Hello everyone, my name's Chris Lehman and I'm a PhD student at the Water Research Laboratory in Sydney, Australia. And today I'd like to talk to you about some of the work I've been doing looking at forecasting storm impacts along regional scale lengths of coastline. What we're seeing here is some drone footage of the aftermath of a large storm that impacted the New South Wales coast in 2016. This particular footage was taken at Narrabeen Colliery Beach, which is a kind of chronic erosion hotspot for those familiar with it. But we had impacts similar to this up and down the entire New South Wales coastline. So my work is focused on how do we actually go about understanding or predicting where these events are going to happen. So how do we go about forecasting storm hazards? Well, at the local scale, we're pretty good. We can use tools like vICCE to really understand the processes and the response of the beach and dune system to any hydrodynamic forcing. But vICCE requires a lot of computational power, it requires calibration, and this is kind of infeasible at the regional scale. This East Coast low event, which we saw footage of earlier, that affected the entire New South Wales coastline, which is about 1,000 kilometers. So we can't really set up a X-beach model at every single beach along the entire coastline, but we still want to be able to understand where we need to be concerned about if we have another event like this. So the problem is, how do we categorize the nature and severity of coastal storm hazards at the regional scale? So diving a bit into this, then when we talk about the nature, it's understanding what type of hazard is it going to be. Is it going to be coastal flooding, where we have really high elevated total water levels? Or is it going to be beach erosion, where the total water level doesn't get too high, but the continued, perhaps long duration of storm combined with high wave energy is going to produce a lot of erosion, which can affect houses, property, infrastructure located close by. The severity, we need to understand how bad is it going to be, how much preparation do we need to do, what's the recovery going to be like, and the other important term in this problem is regional scale. We can't use complicated, computationally expensive methods such as vICCE. We need something that's simple, easy to calculate, and can be applied over thousands of kilometers worth of coastline. So how do we go about doing this? If we look at existing methods of what other people are doing to do this, one approach that comes up is the storm impact scale. So this scale is based on 4 different regimes. So the swash, collision, overwash, and inundation regime. And it looks at basically comparing the dune, toe, and dune crest levels to how high the water level is going to reach during a storm. So if we are not reaching the dune, we're in the swash regime. If we're reaching the dune face, collision. If water's overtopping the dune crest, then we're in the overwash. And if we're completely submerging the dune, then we're in inundation. And so this is a really simple, easy to forecast, easy to predict scale that can give you a sense of what's the general morphodynamic impact of an event like this is going to be. And the USGS actually do this in operation. So you can go to the Coastal Change Hazards portal and they'll give you the probabilities of each one of these regimes during an impending storm. And they're looking at more sophisticated products. So this is an experimental product, which actually shows you the time varying water elevations. So you can actually identify at which times are you going to be in which regimes. And so this is quite good. This is a good place to start if we want to do something like this in Australia. But the US East Coast has a different kind of shelf setting to what we experience in Australia. So if you look at kind of this map where we have Florida, you see quite a wide continental shelf. And so when we get hurricanes or storms, this shallow shelf elevates the water level and we get large variations or large storm surges when an event occurs. If we look at the southeast Australian coast, where we want to implement a system like this, you can immediately see that the continental shelf is quite different. It's quite narrow, it's quite steep. And this has the effect of allowing more wave energy to impact the coast. So here in Australia, we don't get those really elevated high storm surges, but we get more wave energy impacting the coast. And this affects the type of hazard that we're going to experience. And so thinking about this, we can categorize hazards into basically flooding and erosion. So if we think about the storm impact scale, we're adapting what Salinger did and using the 4 regimes defined in that work. So we're kind of looking at swash, collision, overwash, and inundation. But now we're introducing a similar scale, but for erosion. So Salinger looks at the vertical elevation of the water, but the erosion hazard regimes look at the horizontal recession of the result of erosion. And so we we define 4 regimes that look at how much the shoreline is going to change, and that allows us to define whether something is minor or substantially beach narrowing, and then the effect of the dune erosion. So if just the face is eroded, then that's dune erosion, but if the actual crest moves landwards, then that's dune retreat. And so we end up with 4 flooding hazards and 4 erosion hazards, and we can look at combining those and seeing what may occur, which flooding hazard may occur with which erosion hazard. And we end up with this matrix. So on the x-axis we have erosion hazards, on the y-axis we have flooding hazards, and we basically get this matrix. And so grayed out cells represent combinations which wouldn't normally be likely on sandy beaches, but the other boxes kind of indicates the overall severity of this combination of flooding and erosion hazards. So for example, swash, we might have minor or substantial beach narrowing where the water level doesn't impact go above the dune toe. But if we get a long enough storm or more increased wave energy, then we can start to undermine the dune, and that's going to lead to dune face erosion or dune retreat. And similarly for the rest of the combinations. So we can look at applying this to 2 different events and seeing, does this approach, does this matrix actually work, and does it describe or categorize the impacts that we see? And so we've looked at 2 events, one in New South Wales and one in Florida in the US. And these are basically 2 very different events. So if we look at the wave heights, so we have time on the x-axis, wave height on the y-axis, you can see that the New South Wales event was a much longer duration. So we had much more cumulative wave energy impacting our coastline. But in the Santa Rosa Island event, where we're looking at the storm surge, so the green line represents the surge at Santa Rosa Island, and you can see that that is much greater than what the New South Wales coast experienced. And one other key difference is the pre-storm topography of the coastline. So New South Wales has a much more substantial dune system protecting the shoreline, the coastline. Whereas in Santa Rosa Island, it's a low-lying barrier island, so there's not as much protection afforded by the topography there. So looking at New South Wales, we mapped the storm hazard levels across our entire study area, and we see most of them are in this low, moderate, high hazard level region. And we can look at a particular subplot and see what this actually looks like up in more detail. So the bar on the right is what we are looking at in terms of storm hazard level. The flooding hazard and the erosion hazards are also plotted there. But the key difference here is this area here. So if we look at a location north of the embayment and a location south of the embayment, using the erosion hazard regimes, we get dune face erosion and dune retreat in the south. But these actually look quite different when you actually go there, or when you actually look at what was there. So in the north embayment, northern end of the embayment, we had collision, but we only had dune face erosion. So this transect shows that just kind of the tip of the dune was impacted. And you see that the beach still looks fairly fine here. In the southern end of the embayment, we also had collision, but instead of dune face erosion, we had dune retreat. So here the actual crust is moved landwards, and we have it impacting people's properties and damaging infrastructure. And so using the storm hazard level, we get high on the northern end and very high at the southern end. So it's good that we get that actual difference between hazard severities. We can also look at Santa Rosa Island, and in this case, we see a lot of purple here. So this is kind of the very high and severe hazard levels. Not much of a story to tell here. The island is pretty uniform, and we see basically overwash and dune retreat across most of the sections. And this leads to that severe storm hazard level, so worse than what we saw in the New South Wales coastline. And so if we look at kind of the general distribution of what types of regimes and hazard levels we saw here, we can see that for the New South Wales event, the erosion hazards were more variable. So the flooding hazards were just limited to swash and collision, but the different response, the alongshore variability in the hazards were more explained by erosion hazards. If we look at Santa Rosa Island, we see that in a large case, the dune did actually retreat, but there is more variability in the flooding hazards. So in this case, the flooding hazards explain more of the alongshore variability in the different response that we saw. And kind of as we expected, we get very high to severe in Santa Rosa and low to high in New South Wales. So in conclusion, these storms can produce very different responses depending on what kind of hydrodynamics and the coastal setting that you're in. And if you consider flooding and erosion hazards separately, we can better categorize and explain the impacts than just using the flooding hazard scale or the erosion hazard scale. This matrix approach really allows us to get that increased level of detail. And so the future work is how we would actually go about forecasting these erosion hazards. So there are a number of shoreline change models that we can use, a number of dune impact change models that we can use, and that is the focus of future work. So if you would like to get in contact, if you would like to talk to me on GitHub or Twitter, there are my contact details. I'd love to talk to you more about this if anyone else is interested. Otherwise, thank you very much for your time.